All right, folks, welcome back to Rock the JVM. I'm Daniel, and in this video, I'm going to talk about value classes in Scala. Now, value classes solve a larger problem, and I'm going to discuss what that problem is at the beginning of this video. And I'm going to approach it from two angles. I'm going to use a library for Scala 2 and a built-in language feature in Scala 3. So I'm going to approach both of these in this video. Now, as always, I'm going to recommend that you code alongside me, and whenever you need to refresh your memory about this concept, just refer back to this video or to its written form at the blog with the link in the description. All right, so without further ado, let's get to our code. So I have here a Scala 2 project, and right next to that, I also have a Scala 3 project right alongside. So I'm going to approach this from both angles, and in this video, we're going to separate the solutions. First, I'm going to start with Scala 2, and I'm going to describe what the problem is. So I'm going to start with an example. Let's assume that we are working on some kind of online store. We all know and love online stores, and I'm going to define a case class called product. This is the backbone of any data modeling in your online store. Let's say we have a product, and we can identify this product by a code, which is a string, and a description, which is also a string. So this code can mean absolutely anything. It can be a barcode, or it could be some sort of proprietary identifier for your application, and this description can be any string at all. And let's say we have a trait. Let's call this online store backend. I'm going to call this backend for short, and this has two methods to find products. For example, I'm going to say find by code, and I'm going to pass a code as a string, and as a result, from my database, I'm going to return an option product. Maybe I find it, maybe I don't. And I'm going to also define another API method called find by description, more like a regular search in Amazon or in some kind of online store. And I'm going to add description as a string, and I'm going to return a list of products which can match that description. All right, so let's assume we have this small trait with these two API methods. So far so good. And let me give an example of a code, how that could look like. Let's call this a code. Let's say this is 1-12345 and then 12345 or whatever. All right, and I'm going to pass a description as, I don't know, foam mattress for nice sleep, or whatever. All right, so we have two examples that might be used in this API. Now, the problem is that both of these values are strings, which means that if we somehow defined a backend, let's call this a backend equals new backend, and assume you provide some implementations, which I don't really care about. Let's assume that you said a backend dot find by code, and you pass in a code. This is the way you're supposed to call the API. So this is okay. But you can also use, accidentally, you can say a backend dot find by description, and because the code is also a string, you can pass in a code. And this also compiles, but this is a bug. And bugs like these are very hard to catch at runtime, especially if the variables that you use here are somehow named X and, let's say, Y. If some teammate in the team that you're working on for this online backend names these variables X and Y, which makes it hard to identify what role they play in your backend, then these kinds of bugs are very hard to trace. This is also, by the way, why naming variables and methods and classes and traits and stuff like that matters a lot, especially in large teams. So I'm going to rename this a description, and I'm going to rename this variable as well a code. So when you name them properly, it's much harder to write faulty code. But if naming is bad, or even by accident, even if you miss passing a proper value here as an argument to your API, this can cause bugs that are really hard to trace. They can cause lots of pain and production issues. And so we would like to make the compiler somehow signal that we are passing the wrong value here. So this is the problem that we want to solve, and we are going to introduce the concept of value classes in this video to try to solve this without too much overhead. So this is a problem. Now, how do we solve this problem? Well, the first thing that we can think of is to try to wrap these strings, because both are strings, we want to wrap them into two different data structures. So solution one, let's call this solution one, to use case classes. And I'm going to use a case class, let's call this barcode, which wraps a string. And I'm going to define a case class as well, let's call this description, which wraps a piece of text, which is a string. And now in our API, we can define another trait, let's call this backend v2, where we can define method, let's call this find by code, and we can pass a barcode, not a string, as an argument. Let's call this code as barcode. And this will return an option product. And I'm going to also define a find by description with description as a description, and this will return a list product. Now, if I somehow implement this backend v2, let's call this val backend v2 equals new backend v2, where those methods do whatever, the implementations are not really that important. Well, if I do backend v2 dot find by code and I pass in a code, the code will not compile because the code is a string and it needs to be wrapped in a barcode. So it needs to make explicit to the programmer, or rather the programmer needs to make explicit his or her intention to pass in the right value here as an argument. So I'm going to have barcode with the code, and this is better. And I missed the name of the variable again. And this solution is better because it forces the intention from the developer to use the appropriate type. However, this is just a level of indirection behind the same fundamental problem, because I can use, for example, backend v2 dot find by code, and I can use barcode with a description as a constructor argument, and this is still bad. Now, one way to overcome this kind of problem is to override the apply method of the companion object of your case class to return the appropriate value and making sure that the argument matches the conditions that you like. And for this reason, you could do an object barcode where you can define an apply method, which takes a code as a string, and instead of a barcode, you can return something more complicated, like either string or barcode. And we have another video here on the Rock the JVM channel in which we use either as an error handling data structure, as an idiomatic way of handling errors in Scala, and the string is the so-called error type. And here we can do, for example, either cond. And cond takes three arguments. First is a predicate, which is our condition for the code to match the structure that we want. So code matches a regex or regex, defined depending on how you choose to pronounce that. So I'm going to use a digit and then a dash and then 5 digits and then another D5. And in case this predicate matches, I'm going to use new barcode with code. Otherwise, I'm going to return a string. For example, code is invalid. All right. Now, in this case, the apply method returns not a barcode, but an either of a string and barcode. And because of that, you will need to handle the potential errors that you might receive if your argument does not pass your predicate. This is what we want to do. We want the compiler to force us to validate our code argument so that the string actually matches the structure that we intended. Now, this will force us to write a little bit more code, but in the end, we make the compiler force us to write correct code, which is what we intended in the first place. Now, for the sake of brevity, I'm just going to comment these, and introduce another concept, because the fact that we're using case classes to wrap simple values means that we allocate every time we use a code, we allocate a new instance of these case classes. And in high-performance systems, this might cause severe issues, for which we have a solution here in the form of value classes. And I'm going to name these VCs for short. Now, what are value classes? So value classes are normal classes like case class, and I'm going to name this barcode VC. And these classes can only take a value, a val constructor argument, and I'm going to use val for the sake of completeness here, and I'm going to use code as a string, and this extends any val. Now, I'm using val here, which is redundant because case classes automatically promote constructor arguments to fields, so you can leave this aside. But if you define a normal class, your constructor argument must be a val. Now, besides that, you can define no other vals, but just methods. For example, I can define a method called country code, which is a car, for example, and I'm going to say code car at 0. For example, our first digit there. Now, I am fully aware that there are more than 10 countries in the entire world, but just use this method as an illustration. All right, now, what does this extends any val give us? Well, it gives us some benefits. For example, no runtime overhead. What do I mean by that? While the compiler treats barcode VCs as instances of case classes, at runtime, they're treated as actual strings. This is important for the over-allocation problem that I described earlier. However, there are restrictions with using value classes like these, and I'm going to paste this here. So you can only have one val constructor argument. You can have no other vals inside the body of the class, just methods. These classes that you defined as value classes cannot be extended, and these can only extend what's so-called universal traits, like any val. And traits like these only have methods and do no initialization. Now, if these restrictions are a small price to pay for the lack of runtime overhead, which is a big promise and a big benefit, consider some situations where the compiler has no choice but to create bytecode that does instantiation of this case class. First situation concerns generic methods that take arguments. For example, I'm going to define a method called show, which takes a type argument t and an instance, like an argument, of type t, and this returns a string. This is a common method in the cat's show type class, and I'm going to simply return argument.toString for brevity. Now, if I call show on a barcode VC, with, let's say, 1-12345-12345. Now, this causes an instantiation, so barcode VC will be instantiated here. That's because the compiler cannot really tell whether I'm using this instance as a string, which I'm trying to wrap, or as an instance of barcode VC myself. And because we use generics, which are erased at runtime, the compiler has no choice but to create an instance of this class. So when you use value classes with generic methods like these, those case classes, these value classes will be instantiated. So this is drawback 1. Now, there are more situations like these. For example, if you want to assign some of these instances in an array. So if I define, let's call this val barcodes as array of type barcode VC, invoked with a bunch of barcodes, like barcode VC with 1-12345 or -1234 whatever, and a bunch of other barcodes. When you put instances of barcodes in an array, these will also be instantiated as well. That is because the JVM treats arrays of strings differently from arrays of other types, right? So the JVM has the notion of a typed array. So this will cause the compiler to actually instantiate your classes. Now, a third case is when you do pattern matching. So for example, if you do barcode VC with the string 1-12345, 12345, 6 match and let's say case bar code VC with code, and then you do print line code, well, this will actually instantiate the element being matched. So if the first restrictions weren't that big of a deal, this second set of restrictions might cause you to rethink this solution altogether, which is why I'm going to introduce a third solution with value classes with a library called newtypes. Now, newtype is a special kind of library. I'm going to go to my build.sbt and I'm going to add the library definitions and the compiler plugin that you need to add so that the library can work correctly. So you need to add this line to your library dependencies in your build.sbt, io istatico, newtype, and I'm using the latest version at the moment of this recording, 0.44. And you also need to add a compiler plugin for macros because this newtype annotation that I'm going to show you relies on compiler macros. So if you're coding alongside me, put a pause to this video and go to the blog version and add these two lines to your build SBT to code yourself as well. Now, why are new types interesting? Because I can define a case class, let's call this barcode NT from new type, and I can wrap a code as a string, and I can simply add an annotation called @newtype, which I can import. So this annotation activates a bunch of compiler macros that will generate a value class out of this. And that value class will not have these issues over here. So you have a VC without issues D1 to 3 that I named here in the comments. So this is pretty cool, which you can also add with a single line of code, and the macros will take care of themselves. And if you want to overcome the problem that I described earlier, where you can accidentally pass a description for a code, you can also overwrite the apply method in the barcode NT companion object, and that will work just as fine. Now, a good practice for doing such a thing would be to define an object, let's call this barcode NT, where the apply method will take a code as a string, and this will return not barcode NT, but an either with a string or a barcode NT. And I'm going to follow a similar pattern, either cond, and I'm going to follow a similar pattern that I wrote here above. I'm going to copy and paste these, and instead of new barcode with the string, I'm going to use code.coerce. Coerce is a very interesting method. First of all, it needs its own import, so I'm importing io istatico newtype ops underscore. And this creates a bunch of implicits, also generated via macros. Implicits will allow you to convert from a code, which is a string, to one of these case classes, and vice versa. So it allows you to convert between both of these types. So this piece that you're seeing right here is kind of the best solution that you can obtain in Scala 2 for the kind of problem that we wanted to solve. The subtle bugs that we wanted to catch so that the compiler forces you to use the right type without runtime overhead and without the problems that I outlined here above. Now, in the blog version, I also have more information about how this coerce method actually works behind the scenes and how new types can be combined with libraries like cats to automatically derive type classes for our new types. So this was in Scala 2. Now in Scala 3, we have a simpler language level feature for this exact use case, and it's called opaque types. Now, I have a dedicated video on opaque types here on the Rock the JVM channel if you want to check it out, where we explain the mechanics of opaque types, but not necessarily why or where they are actually useful. And this is a use case for opaque types. So opaque types are type aliases, type bar code equals string, but with the keyword opaque in front of it. And opaque means that you can use this barcode type outside of the scope that it's defined, in this case the value class is object, and you can use barcodes and strings interchangeably, and this type has its own API, so it hides away all of the strings APIs. So this is basically equivalent to our new type that we wrote earlier, except we don't need any libraries or compiler macros or compiler extensions or any of that sort. Now, if we wanted to obtain a barcode like this through a smart constructor, like the apply method that we wrote earlier in the companion object for the type that we wanted to show, we can do the same thing here. So I'm going to define an object, let's call this barcode, and inside I can define an apply method. So I'm going to say apply with a code as a string, and I'm going to return an either with string and barcode. And I can follow the exact same pattern, except I don't have to wrap this thing into a string or wrap a string into a barcode. So I'm going to copy this code with either cond, and I'm going to move this to my other project. So I'm going to say either cond, and I'm going to say code matches this thing, and instead of code coerce, I'm going to simply use code itself, because barcode and string are interchangeable in the scope that they're defined. But outside this scope, barcodes and strings are two completely unrelated types. So I'm going to define an object here, let's call this usage site, where we use instances of these barcodes, for example, in our backend API. And if I want to create a barcode as a barcode, first of all, you need to import the type. So I'm going to import value classes dot underscore, for example. And if on the right hand side I use a string like 1-12345 this is not compilable code, because on the right hand side we have a string, and on the left hand side we have a barcode, and the compiler treats these two as completely separate types. And so you have no choice but to use the smart constructor here, like barcode.apply, and then you can pass in your code 12345, and now, because this thing returns an either, then you need to do pattern matching on it if you want to return a barcode. But otherwise, you can say barcode apply or barcode with this instance over here with this string, and then you can use map or for each, and then you can call your backend API. All right, because now inside the for each call, if you have a code, then you can do whatever you want with it. So this is how you can solve the problem the value classes try to solve in Scala 3. Quick and easy, no downsides, no runtime overhead, and none of the fake accidental instantiations that we had earlier with our own value classes in Scala 2. So from this point of view, Scala 3 is a massive improvement. So I hope this video was useful and fun, and that you will make use of these new concepts in your day-to-day Scala work. Now, if you like this video, go ahead and click the like button for me and subscribe to the channel for more videos like this, and follow me on Twitter and LinkedIn. I post fresh updates all the time. Also, check out the blog, which you can find in the link in the description below, and check out the Rock the JVM website. I have tons of material on Scala and functional programming and Apache Spark and Akka and Cats and so on and so on. Until next time, Daniel signing off.